Now I am coming to discuss about some problems on Joule's experiment. The Joule's experiment have already been discussed in previous video. Now some problems about that is discussed here. I suggest that you may take screenshot in each step or you may note down. Now question is, for this type of gas equation, what is the value of del u del Vt? Okay. So just like previous problems, here start as del u del Vt is equal to T del P del T V minus P. This is the thermodynamic equation of state. I shall derive this later. Now you keep in mind this equation because this is a most important equation in thermodynamics. Del u del Vt. Okay. So here we need to obtain the value of del P del T V first. So here only pressure is differentiated with temperature. So I must come from this equation, start from this equation. Here as del P del T V is required, so here only pressure and temperature terms may be in left hand side, or only pressure related terms keep in left hand side and rest are at right hand side. Then here P is equal to inner T by V minus NV. Now here R is universal constant, and in our experiment the value of N, B, these are also constant, and as we shall try to obtain value of del P del T at constant V, because here V is in suffix. So here V is also constant, that is volume is constant or unchanged here. This is by question we obtain the value of del P del T at constant V. So here only temperature is variable and rest part is constant. So this can be when we differentiate this pressure with temperature at constant volume, then here all are constants, so just repeat these constants first and then differentiate this temperature with temperature. Now differentiation of temperature with temperature give value of 1, because if we differentiate x with respect to x, then we obtain 1. So here 1, that is here inner by V minus NV. This is the value of del P del T V. Now put this in this equation. Then what we obtain? Then we obtain that del u del Vt is equal to T into value of del P del T V is inner by V minus NV. Just I derived this just few seconds ago, minus P. Okay. Now this can be written as inner T by V minus NV. minus P. Now this inactive by V minus NV is equal to P according to this equation, because if here we rewrite this equation as, then we get inactive by V minus NV is equal to P. Just from here, just we keep this pressure term in left hand side and the V minus NV to right hand side. Okay, which gives this. So here in place of inactive by V minus NV, we may write P, and P minus P gives 0. So value of del U del Vt in this gas is 0. Now in exam, this type of many equations may be given. Then in each step, first rewrite the equation, then use the thermodynamic equation of state, then from this equation we have to obtain the value of del P del Tv. To obtain this, the pressure related terms are at left hand side and rest are at right hand side, and this format you may divide and then differentiate the pressure with respect to temperature, and then put the value of del P del Tv to in the thermodynamic equation of state and obtain del U del Vt. If here this is like this, for this gas equation, what is the value of del U del Vt? So here are P plus N square by V square is equal to inactive by V, then P is equal to inactive by V minus N square by V square. So here only pressure related term keep at left hand side, then differentiate this with respect to temperature at constant volume. So here N is constant, R is constant, and as this differentiation is at constant volume, so here V is also constant. So here first write the constant term and then differentiation of temperature with respect to temperature give value 1 minus here A constant, N constant, and by equation V is also constant, as here we differentiate the pressure with respect to temperature at constant volume, because this is a partial differentiation. So then here the differentiation of this constant quantity with temperature give value of 0, because differentiation of any constant with respect to any variable give 0 always. So here nr by V. Now del P del Tv is equal to nr by V. Put this to this equation, and we then obtain that del U del Vt is equal to T here nr by V in place of del P del Tv. Just I have derived this previously minus P. Now here put the temperature in parentheses, then P by V minus P. Now from this gas equation, what is the value of inactive by V? Now, P plus N square by V square is equal to inactive by V. So inactive by V is equal to P plus N square by V square. So here we may write P plus N square by V square in place of it. That is P plus N square by V square minus P. Now cancel out PP, then n square by v square. So this is the value of del u del Vt for this gas equation. So here the gas equation may be anything, but the process is same in each case. I just summarize these points as to obtain del u del Vt for a given gas equation, first use del u del Vt is equal to T del P del dV minus P. Then if all pressure related term in left hand side and rest at right hand side. Then consider volume as constant. Then differentiate pressure with respect to temperature. With respect to temperature. Then put the value of del P del Tv in this equation. Say this is equation 1. Then from here, after putting the value of del P del Tv to here, this total part, value of total part is taken from the original gas equation. Okay. From given gas equation and put in equation 1, and then after cancelled out the pressure terms, you get the value of del u del Vt. Okay. These are the steps. You must take screenshot of these steps. And another type of problems are what is the value of del u del P T for any gas equation like this, PV is equal to nRT. To obtain this, just use this del u del Pt is equal to del u del Vt into del V del Pt. Okay. Now for this gas equation del u del Vt is equal to 0, we have obtained this in previous videos. So here this gives 0 into del V del Vt. So total is 0. Okay. So here only one thing is del u del Vt is equal to del u del Vt into del V del Vt, because in anything, say del x del y at constant p, say at constant q, you may write this as that del x del z, you arbitrarily choose this variable z at constant q into del z by del y at constant q. Okay. So here this. And value of del H del Vt. The physical here H is called enthalpy. Physical significance of enthalpy, definition of enthalpy. These all are shall be discussed later. Now, just keep in mind this equation that H is equal to U plus PV. Okay. So then, to obtain del H del Pt, the del H del Pt first. Okay, here del H del Pt for this PV is equal to nRT, that is isothermal ideal gas equation for this. Okay. Achha. So for this del U del Vt is equal to 0 from Joule's experiment, as these all are applications of Joule's experiment. So in each case the value of del U del Vt is required, and the required equation must be convert to the del U del Vt format as here del H del Pt is equal to del H del Vt into del V del Pt, just like previous. Now from here del H del Vt, okay, to obtain del H del Vt first use as PV is equal to nRT, so here we may write nRT, here n constant, r constant, and T is also constant here, as here the T is constant in the differentiation, because here T is in suffix. So here del H del Vt is equal to del U del Vt plus del nRT del T del Vt. As here T is constant, so as here T is constant, so here T can be taken as constant, then differentiation of this constant with respect to any variable must be 0. Because here n constant, r constant, only T is variable, but if T is constant then this gives 0. So here we may write plus 0, that is del H del Vt is equal to del U del Vt. So we may write here del U del Vt into del V del Vt. Now del U del Vt for this gas is 0, which has been obtained from Joule's experiment. So here put 0 into del V del Pt, as this is non-zero, so this is 0, this is 0. So del H del Pt is equal to 0. So to obtain del H del Pt or del U del Pt, first use it in volume format. Then I just summarize these points again. Yes. To obtain del U del Pt, first rewrite it as del U del Pt is equal to del U del Vt. Must use this del U del Vt format because this is only obtained from Joule's experiment. And then put the value of del U del Vt for the given gas equation and you get del U del Pt. And to obtain del H del Pt, for del H del Pt, first use H is equal to U plus Pv, then U plus inactivity, so this is constant, then you first obtain del H del Vt, which give del U del Vt, which is equal to del U del Vt plus 0, and then put the value of del U del Vt and then rewrite this del H del Vt as del H del Vt into del V del Vt. And from here del H del Vt is also 0, so this is 0, this give 0, plus this is also 0, so this is 0, so this is 0, so here 0 into 0 is equal to 0. Okay, very easy. Just you need to practice just one time and then continue this practice in every week for one time for just 2-3 weeks. Then you keep in mind this. If you have any queries, then feel free to contact with me at this number. Or you may ask that in comment section. Okay. Okay. Thank you. Good night.